Hi and welcome back to Flypath Pioneers. I'm Walter. I'm a CFII. By teaching these lessons, I'm only really teaching myself. Right, is reminding myself as well as becoming a more effective teacher to other aviators in the future. So join me on this journey. We're going to go into the last component of the basic aerodynamics. We'll talk a little bit about the rotor systems and vibrations in the aircraft. Of course, if you have any questions or clarifications, by all means add to the comments. I have thick skin, so don't be afraid to say that if I did something or said something wrong, or I can do it in a better way, because we're all here to continue to learn. So thank you and for joining me today, and I hope, of course, you take something out of it. All right, let's talk about the rotor systems, as we have three distinctive different types of systems out there. You will hear often, too often, my helicopter is better than yours, or I would never fly a Robinson helicopter, or I would never have a three-bladed or a two-engine or a one-engine. Listen, there's a lot of opinions by a lot of people, and I have to say this, that we all have to remember where we started, and most of us started in simple helicopter flying, like a Robinson or a Schweitzer or something like that. All of them have shown to be able to hold its weight in their own class. Right? It is that if we have unlimited funds, of course, we want to go to a rigid system that provides safety and margins, and but of course with complexity comes cost. So we're going to talk a little bit and break that down in today's session itself. So first, the basics, and this is for rotor systems, and they play slightly different from one system to another system. But four things that we want to think about as it comes to the rotor blades. One is the flapping, and it's one blade at a time. Right? It's the ability of the rotor blades to move in a vertical direction, can be independent or together. The flapping hinge allows this to happen, attaches to the rotor blade, to the rotor hub itself. But again, this is so very important. Again, go out to the helicopter, climb on top, and really carefully look at, take the example in the top right hand corner, and start understanding the components. Of course, we're talking here about a Robinson 22 or 44, but it is something very, very important to be able to understand how it all functions in order to be able to. Now, what we're not going to talk about today is the flapping, about changing the angle of attack, or the leading, or the trailing. All that stuff will come in lessons to come. We just want to think about the mechanical functions of the blade systems that we have today. So after the flapping comes teeter, where both of the blades, right, the rotor hub attaches to the teeter hinge, which allows the blades to teeter up and down in unison. Think of a seesaw. So literally, when you're on top and maybe have your instructor gently move the tip plane, right, the front downwards, and you can see that it's like a seesaw, right? And that, remember, in flight, some of that is taking place as well. The feathering is changing of the pitch angle of rotor blades by rotating them, and this is allowing the airfoil to change the pitch angle itself. Right? And you go look at that. Now, it's a little difficult to simulate it on the ground, but it is just one of the actions. The lead and leg, by the way, is unique to the three or more blades, not to the Robinson or the two-bladed systems that you might be familiar with. So the leading and legging of the blades itself, it allows for forward and backward movement of the rotor blade along the plane of rotation itself. So we're still moving, but they can go backward and forwards in order to be able to provide a smoother ride. And in the helicopter itself, there is one downside of resonance that can take place. So let's look at the three different types that we have here. We have a semi-rigid system, which is in the Robinson helicopters. It's two-bladed. It's able to teeter flap as a unit and feather. Right? This is it is cheaper. Right? They're easy to maintain, relatively light and small. Makes for easier storage because it has two blades. The footprint is rather small, but we have to be mindful of a potential of mass bumping itself. And I'll go back to that in just 2 seconds. The second type of system is a fully articulated system. That is a system where you have three or more blades. It's able to feather, flap, and lead and leg independent of each other. It often is better for a smooth flight, and you don't have to worry about any kind of mass bumping. It is certainly more expensive. Of course, the high end where you have no longer hinges, but you have systems that work together under in a rigid system where you have 3 more blades. It absorbs the operating load of the lead leg by bending rather than hinges. Right? So it's mechanically it is simpler. Of course, it also is far more expensive. No worry about mast bumping here. And it is very reliable and easy to maintain, but it's very expensive up front, right? Because of the complexities of the blades itself, and you have usually 3, 4, 5 or more blades on an aircraft. So again, cost matters, especially as you start out and you have limited funds available. So going back to the semi-rigid system that we have on the Robinson helicopter, so as you climb on top and you look at the rotor head, look inside where you can actually see how we are underslung, right? Where you see you have the teeter hinge on top, that's the bolt on top. Look on the side of the mast itself, right? That's the gray mast that's coming through the roof. Up above, there's 2 little rubber stoppers on each side of that. That is to help with potential, mast bumping itself. So that's one of the downsides of the helicopter. But again, if you operate within the safety margin, within the performance specs of that particular aircraft, and you don't have any low G, push forward, you should be able to avoid that. Right? It can be detrimental if you don't. So it's something you will learn early on in training that you, as part of your SFAR 72 training, that you have to be careful there's no cyclic push forward and low G needs to be avoided. Of course, you see here the different mechanical functions of the flapping, feathering, lead, and leg. Again, if you go online and you specifically ask for the question, if you want to learn more about that, there's some very interesting mechanical, these are more drawings than anything else, that you can see the function in flight itself, which might help deepen your understanding of the blade system. The next thing is vibrations. And like everything else in flight, if I have 200 hours, just shy of that, but I feel it's very different than a pilot who's done it for 500, 1,000, or 5,000 or 10,000 hours, right? But, vibrations can tell us something, so we do need to be very sensitive about that. One of the things that you will learn as you should make it a habit and not break that habit. Part of your startup procedure, you don't have your headset on. Right, as you start it up, you're listening to all of the components coming together. You feel the vibrations, and if there's anything that is abnormal, it's you can pick it up pretty quickly. Of course, in flight itself, there too, you need to be very mindful about that. And if you feel something that changes, you have to ask yourself the question: why is that, and where is it coming from? Because they could potentially be early indicators that something is not right. Right. So yes, the helicopter will always vibrate. You have different messages that can be sent. So, for example, a low vibration can be is likely the main rotor, right? It's felt to the cyclic and the airframe, and it can be felt like bumps. It's felt as an up and down motion, or engine vibrations can also have a low frequency when issues with ignition come up itself. So that's right at startup itself. The medium, it would be likely the engine. It felt in the lower back of your seat. It's caused by out-of-balance components such as the transmission, the drive shafts, the pulleys, and the belts. Or you have high frequency, which is the tail rotor. Of course, it spins it fastest. Is felt in your pedals, and again, caused by a balance component such as the tail rotor or uneven or during a loss of tail rotor effectiveness itself. Again, learning to feel this comes with time. Right, but be sensitive about that. All right, that ends this particular component. I hope that you enjoyed it, and we'll talk to you in the next lesson again.